I So another study that is done, I don't know how frequently in your institution, but I know at Emory they are often doing viability studies with FDG, and so we have a viability tool. So this is a resting perfusion rubidium scan and then an FDG scan, and you can see the two, and then from there we can actually calculate a match mismatch. So the resting perfusion scan is submitted to a normal file, and then if there's a defect, that would be highlighted. And then if there's FDG, there's FDG uptake within that defect that falls above the threshold. By default, that's 15% of the maximum in the FDG study. Then it would color that white. And so now we're looking at a mismatch between perfusion and FDG, and that's highlighted in white. And we can show that on the polar maps, this extent mass page as well. So it's going to show you the mismatch, and in this case, the vast majority of this is a mismatch. 96% of the entire defect is a mismatch, and about 4% is a match, and the match would be just these fringe pixels that you see here. So it's just a nice way to actually do an actual quantitative measure of viability studies when looking at FDG. And it doesn't have to be rubidium. It could have been a spec study that's brought in for the perfusion. Again, typically at Emory, since they're doing the FDG on the PET scanner, they go ahead and do the rubidium on the PET scanner, but it can be done however you want to do that. And I think one of the